Our first problem says Rob's fruit farm consists of 100 acres on which 3 different types of apples grow. On 25 acres, the farm grows Empire apples. McIntosh apples grow on 30% of the farm, and the remainder of the farm grows Fuji apples. Shade in the grid below to represent the portion of the farm each type of apple occupies. Use a different color for each type of apple and create a key to identify that. So, when we think about what we have, the first one is we have 25 acres are Empire apples, and this is on a 100-acre farm. So down below, I have a 100 square grid, and so 25 of those 100 acres are Empire apples. So my color for Empire is purple, and I need to color in 25 boxes. So I have 10, 20, 1, 2, 3, 4, 5. So there's my 25 acres of Empire apples. The next one are McIntosh apples, which is 30%. So McIntosh is going to be pink, and 30% of my farm would be another 30 boxes. So I'm going to go from the other side. 10, 20, and 30. So I colored in a full 30 boxes. And lastly, it says the remainder of my farm grow Fuji apples. So Fuji is going to be green, and it's going to be the rest of my boxes. And so what I need to do next, after I have my coloring done, is I need to go ahead and figure out my part to whole ratio. And we can represent ratios in different ways, but for starting with the Empire apples, I have 25 acres. So I had 25 out of 100 acres. I know this could also be written as 25%. My next apple was McIntosh. And when I looked at my McIntosh apples, they said it was 30% of my fields. And when I colored in 30%, that was 30 out of 100 boxes. And then everything else was Fuji. So I actually have to go ahead and count how much is left. So I have 40 boxes here and 5 here. So that was 45 out of my 100 boxes, which I know would be 45% of my grid. Number 2 says that for each figure, represent the gray shaded region as a percent of the whole figure. Write your answer as decimal, fraction, and percent. So we have to make sure that we represent our answer in 3 different forms this time, instead of just the fraction and percent. And so looking at picture A, we want to look at just the dark gray shaded ones for this one. So I see I have these boxes are shaded in dark gray, which is 20 boxes. So when I think about my fraction, it's 20 out of 100 boxes. But anytime we have fractions, they really should be reduced. So I know we can actually divide top and bottom by 20. So my fraction is 1/5. 1 out of every 5 boxes is shaded. If my fraction is 20 out of 100, that would be 20%. And then my decimal and my fraction actually sound the same. So my fraction is 20 hundredths. And as a decimal, it would be 20 hundredths, or 0.20. You could also see it as 0.2. All of these numbers are the same. My next picture, looking at just our dark gray shaded region, which is this part here, I have to figure out first how many boxes. If I count that up, it's 25 boxes. So my fraction is 25 out of the 100 boxes. I want to reduce my fraction, so they're both divisible by 25, which is actually 1/4 of that image. Now, if we look at our previous problem, we can actually make some connections among the 20 over 100. Notice it's just 20%. So if it's 25 over 100, it would be just 25%. And then also, remember, my fraction and my decimal sounds the same. 25 hundredths is 0.25 or 25 hundredths. These two things are going to sound the same. And lastly, we have picture C. So this time we actually have to be a little more careful in our counting. We have 1, 2, well, I know this top row is 10 here and 10 here. So that's 20. And then if I have 8 and 8, that's 20 and 16. So I'm up to 36. And then I have just a few more boxes to count. 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So if I counted correctly, which I hope I did, I got 48. So I see 48 out of 100 boxes are shaded. I know I have to make it smaller, so they're both divisible by 4. So I have 12 over 25 for my reduced fraction. But remember those connections. My top number, 48, well, that's my percent, 48%. And my decimal is 0.48. And remember that fraction and the decimal sound the same. 48 hundredths, 48 hundredths. Our next problem is another conversion between percent, decimal, fraction, ratio, and model. So when we're given 6%, anytime I'm given a percent, I like to do percent to fraction first before I go back and write my decimal. Because I know my percent at 6% is always going to be a fraction over 100. It's this number over 100. So I have 6 over 100. But we do have to reduce, so I know that I can divide by 2. And I get 3 over 50. So I got my fraction. And remember, when my fraction's over 100, it sounds the same as that decimal. So 6 hundredths is 0.06, which is also 6 hundredths. The ratio is 6 to 100. Remember, we can also write a ratio as a fraction or with the word 2. Those all three are the same ratio. And then my model, 6% or 6 boxes. Colored in my 6. There I go. That's out of 100 boxes. Now, when I have 60%, remember I like to go from percent to fraction, so I know it's going to be 60 over 100. But I know I can divide both of these by 20 to reduce, and you get 3 over 5. Now, 60 hundredths, that's going to sound the same as my decimal, which is 0.60 or 60 hundredths. We don't need that last 0, though, so we could actually write 0.6, which is 6/10 as well. So my ratio is 60 to 100. Or you could write 60 over 100 or 60 colon 100. Those are all 3 ways of writing the same ratio. And on a hundreds grid, I know I have to fill in 60 boxes. So I have 10, 20, 30, 40, 50, 60. And then last but not least, 600%. I know I take that number and I'm going to put it over 100 for my fraction. So I'm going to do 600 over 100. Reduce that. So I'm going to divide by 6 and divide by 6. Nope, can't do that. Divide by 100. And I get 6 over 1 or 6. Now, if my fraction reduces to simply 6, that is 6 wholes. So as a decimal, it'd be 6.0 or 6 wholes. And then my ratio would be 600 colon 100. Could always write that in all 3 ways. Now, when I draw that image, it's going to look a little different. I need just 6 whole items. So instead of doing 6 100 grids, I'm going to just draw 6 items. 2, 3, 4, 5, 6. And I would assume that I would have all of these. So I have all 600 filled in. Another thing I would like to remind you guys about is that when you are going from percent to decimal, so if you're just moving from percent to decimal, you can do that without your fraction. And what you do is you take your percent and you move your decimal 2 to the left. So it's 60%, my decimal's here. If I move it 2 to the left, it becomes 0.60. 600, my decimal is at the end. 2 to the left, it ends up between the 6 and the 0. So there's a lot of different ways of converting between percents, fractions, and decimals, but this is one method. And our last problem says, Mr. Brown shares with the class that 70% of the students got an A on the English vocab quiz. If Mr. Brown has 100 students, create a model to show how many students received an A on the quiz. So what I need you guys to do is I need you to draw out of our 100 student model, 70% that got an A. So create a model, then come back and check it. So on my model, I had a 100 grid, and I colored in 70 of the boxes. Now, what fractions of the student received the A? I know 70% is the same as 70 over 100 for my fraction. If I reduce it, they both divide by 10 because they both end in 0, so I get 7/10. This number as a decimal, remember we talked about from a percent to decimal, we take our decimal and we move it to left. So 70 becomes 0.70. 700ths, my fraction sounds the same as my decimal, but we don't need this extra 0 on the end, so you could also write 0.7, which is actually my tenths, 7/10 and 7/10. They're all the same, just we have some that are more reduced. And then lastly, how are the decimal, fraction, and percent all related? So I want you to come up with that answer on your own. So on your own, and then get it checked off with a teacher.